Okay, now that we've kind of reviewed a little bit what are sine, cosine, and tangent, how do we use them to find angles, let's talk about how we can use sine, cosine, and tangent, or SOHCAHTOA, to find missing side lengths of triangles. So we've got some steps up here that we're going to follow. I would encourage you to use these as you're working through your homework. So the first thing you're going to do when you see a problem like this, like in example A, you're gonna know in these problems you have an angle and you have a side length that you know. So in this case, we know angle 29, that the angle is 29 degrees, and then we know that the top of that triangle is 16 long. We're trying to find the x value, which is the side length over there. So what you're gonna do first is, let me just make this pen a little bit smaller so I can. This, wherever your angle is, that's gonna be your theta. So this angle over here is my theta value. So I'm going to start by labeling my sides opposite, hypotenuse, and adjacent. Remember that the opposite is across from your theta and the hypotenuse is across from your right angle. Now notice that we don't know all of the sides of our triangle. I know the hypotenuse and I care about the opposite. I don't know what the opposite is, but that's what I want to know. Notice that I didn't box in the adjacent side because I don't know the adjacent side, and I really don't care about the adjacent side either. So what I'm going to do is I'm going to use the opposite and the hypotenuse, which is the sine. So I always start by saying, okay, the sine of theta is equal to the opposite over the hypotenuse. That's kind of my starting point for all of these. Then I'm just going to start plugging in everything that I know. So I know what theta is because theta is my angle. So I know that for theta I can put in 29. And the opposite I don't know, that's my x value. And the hypotenuse is 16. So I've plugged in everything that I know. Now my goal is to get the x by itself. So notice that on the right side of the equation, the x is being divided by 16. So to cancel that out, I'm going to multiply both sides of my equation by 16. What that does for me is that it gets the x by itself. So now I have 16 sine of 29 is equal to x. Once the x is by itself, this is easy. I just type into my calculator 16 sine of 29. It should look exactly like this, except for in your calculator you'll have parentheses around that 29. And you should get 7.8 if you round it to one decimal place. And that's what your x is equal to. One thing to notice here is that when you're typing it into the calculator, you are not using the inverse sign. It's not the sign that has the -1 with it. It's just the regular old sign button. Okay? Let's do another one. So if I look at B, the first thing I'm going to do is I'm going to put my theta wherever the angle is, and then I'm going to label my sides. I have the hypotenuse, the opposite, and the adjacent. Then you're going to think about the sides that you know. I know my I don't know my opposite, but I want to know the opposite. And I know the adjacent. I don't care about the hypotenuse, I'm just going to ignore it. And then I'm going to think. I'm going to think back to SOHCAHTOA. Let's write it up here again. Which of those three deals with the opposite and the adjacent? Well, that's the TOA piece, which is the tangent. So I'm going to start with the tangent of theta is equal to the opposite over the adjacent. Then start filling in what I know. So I know the tangent of 64 is equal to the opposite, which is x, over the adjacent, which is 14. Then I want to get rid of my fraction, so I'm just going to multiply both sides by 14, which gives me 14 tangent of 64. Oops, that's a 4, not a 64, is equal to x. Then I'm going to take that, punch it into my calculator, and I'm going to get 28.7 is equal to x. Now remember, what we just found, this 28.7, that's a side length. So if I were to go up to that triangle, that top side length, the x value is 28.7 long. All right, let's do another one. First thing I'm going to do, put my theta where my angle is, label my sides, opposite, adjacent, and hypotenuse. And then I've got to decide which trig function to use. So I know the hypotenuse, and I want to know the adjacent. So that means I'm going to use the cosine. Let's do it over here. So the cosine of my angle, cosine of 58, is equal to the adjacent side length over the hypotenuse. I'm going to get rid of my fraction by multiplying both sides by 18. So then 18 cosine of 58 is equal to x. Okay, so my x is equal to 9.5. Now, one thing that I would do as I'm doing these problems is I would look back and make sure your final answer makes sense in the problem. So, for example, I got 9.5, so I'm saying that the base of this triangle is 9.5. That seems reasonable since the hypotenuse was 18. An unreasonable answer might be like 0.3. That would be a pretty small length if the hypotenuse is 18. Or if I got anything bigger than 18. So if I got like 20 for that side length, that would be incorrect too. So I would always check and just make sure that your answer seems reasonable based on the triangle you've been given. Okay. A lot of you guys are going to be tempted to skip steps when you're doing these problems. You're going to be tempted to not write all the steps down. When you're doing your homework, you need to, very minimum, give me this original equation that you set up. That would be like the bare minimum amount of work that you should show. I recommend showing a lot more than that. Okay, let's look at some other ones. So far, hopefully you're feeling pretty comfortable with these first 3 examples. The next 3 are going to start off the same, but they are going to end up being a little bit different. So I'm going to start putting my theta where my angle is, and then I'm going to label the sides. Hypotenuse, opposite, adjacent. I'm going to use the hypotenuse and the adjacent. I could care less about the opposite, so I'm not going to use it. So I'm going to use the cosine function because the cosine connects the adjacent and the hypotenuse. So the cosine of 65 is equal to the adjacent side length over x. Now, this setup looks a little bit different because if you'll notice, in the first 3 examples we did, our x value was on the top of our fraction. Now it's on the bottom. So our first step is going to be to multiply by x. We have to get rid of our fraction to start with. So I get rid of my fraction, and now I'm left with x cosine of 65 is equal to 12, which is great, but the x still is not by itself, and my goal is to get the x by itself. So right here, I'm multiplying x times the cosine of 50. So to undo that multiplying, I'm going to divide by the whole cosine of 65. That cosine and 65 are glued together, so you have to divide by that whole piece. So then, my answer will be x equals 12 divided by the cosine of 65. Now that the x is by itself, you're going to type that into your calculator. 12, and you're going to hit the divided by sign. So 12 divided by 65 is equal to 28.4. That's my x value for this one. Okay. All right, let's do another example of this. I'm going to go ahead and separate these 2 problems. Okay. Sorry, I want this other blue. Okay, so I'm going to put my theta where my angle is. Your theta should always be at an angle that's not the right angle. I'm going to label my sides. I've got the hypotenuse up here, the opposite, the adjacent, and then I want to use the opposite and the adjacent in my problem. So that's going to be the tangent. So the tangent of my angle, 71, is equal to the opposite side length over the adjacent side length. So 16 over x. Start by getting rid of your fraction. That's always just a good place to start, I think. So I have x tangent of 71 is equal to 16. Then I'm going to divide by the tangent of 71, that whole entire piece. So x is equal to 16 over the tangent of 71. Type that into your calculator, and you're going to get 5.5 for your x value. Okay. All right. Let's go ahead and do one more together, and then we'll talk about a few patterns that you guys might be seeing. So I'm going to go ahead and separate these again so I don't mess them up. I'm going to put my theta where my angle is, label my sides, hypotenuse, opposite, and then adjacent. I'm going to use let me get my red marker out, my opposite and my hypotenuse. Think back to SOHCAHTOA. Opposite and hypotenuse is the sine. So the sine of 26 is equal to the opposite over the hypotenuse. Multiply both sides by my x value. So x sine of 26 is equal to 12. Divide both sides by the sine of 26. And you're going to get that x is equal to 12 over the sine of 26, which is equal to 27.4. Okay, so that is how you work through solving these types of problems. If you are feeling confident on what we've done so far, you are welcome to pause the video and work on your homework now. Before you do so, though, I want you to notice that there's some patterns. Sometimes we're doing the side length times, like 16 times the sine of 29. Sometimes we're dividing, like 12 divided by the cosine of 65. This is why I would highly recommend not skipping steps. Show all of your work. How did you get from, your initial setup to where your x is by itself? Show all of those steps, and you're going to minimize how many mistakes you make. So don't try to take so many shortcuts that you end up with the wrong answer. So if you're feeling pretty confident, go ahead and jump to your homework. You are going to want to do numbers 1 through 14 before coming back and watching the next video. Skip number 15. It's actually an impossible problem, so just cross it off. If you need some more practice, stay on the video. I'm going to work through these last three examples, and then you can go to your homework. So in these next 3 examples, I am going to put my theta where the angle is, and then label the sides opposite, hypotenuse, adjacent. My opposite is 15, and my adjacent is x. So I'm going to use the tangent, because the tangent is the ratio that deals with the opposite and the adjacent. So tangent of 57 is 15 over x. I will multiply both sides by my x value. So x tangent of 57 is equal to 15. Divide both sides by the tangent of 57. Punch that into my calculator, and x is equal to 9.7. And again, checking the reasonableness of your answer is a good idea. If one side of my triangle is 15, it seems plausible that the other side could be 9.7. Okay. Alrighty, let's do another one. Put my theta down, label my sides, hypotenuse, opposite, adjacent. Okay. I have the hypotenuse and I have the adjacent, so I am going to use the cosine. So the cosine of 43 is equal to x over 15. I'm going to multiply both sides by 15, so 15 cosine of 43 is equal to x. Notice that at this point my x is by itself. I do not have to do any dividing because the x is by itself. So let's just type in 15 cosine of 43. I'm going to get 10.97, which is going to round up to 11, is equal to x. This is a good example of, you want to make sure you show all your steps. Right when your x is by itself, you know you're ready to type it into your calculator. Okay, last one. Theta goes on the 38. Label my side lengths, opposite, adjacent, and hypotenuse. I have the opposite and I have the hypotenuse. So that is going to tell me that I'm going to use the sine. So the sine of 38 is equal to the opposite over the hypotenuse. First step is to get rid of my fractions. So I have x sine of 38 is equal to 19. The x is not by itself, so I do need to do another step here. Divide it by the sine of 38. So x is equal to 19 over the sine of 38. Punch that into my calculator, and I am going to get 30.9. All right. So you're done this video. You are ready to go to your homework now. You are doing numbers 4 through 14. And just like before, you are skipping number 15.